this video, we are going to review the proper steps for installation of a Warner Electric normal duty or pin drive electrically released brake. Vertical mounting installations of electrically released brakes should be reviewed by Warner Electric application support prior to usage. Please observe proper lockout and tagout procedures for safety's sake. Please note that for this installation you will need to power the brake independent of other machine functions. Before starting, let's review the requirements for installing an electrically released permanent magnet type brake. You'll need a flathead screwdriver and Allen wrenches to install wires and fasteners, a set of steel shims 1/16 inch thick and at least 2 inches long, a torque wrench with capability to match the rating of the brake you're installing. The mounting surface for the brake magnet must be a non-magnetic surface at least a ½ inch thick. And finally, you'll need an adjustable output power supply. Before we start with the actual step-by-step installation, let's make sure we're clear on the nature of the Warner Electric ER or electrically released brake. Electrically released brakes will release, that is, disengage, when power is applied. When power is removed, the brake will engage. The magnet assembly for an electrically released permanent magnet brake includes a set of permanent magnets in addition to the standard coil. These permanent magnets provide the magnetism that causes the armature to engage against the magnet. To release or disengage the brake, DC power is applied. The electromagnetism created in the coil creates a magnetic field that offsets the magnetism from the permanent magnets. As we approach mounting the unit, you'll want to keep the armature and magnet separate from each other. Do not place the armature near the magnet until you are ready to mount. If you mistakenly get the armature and magnet clamped together, apply power to them to disengage them. Do not pry them apart. This will only bend the armature out of flatness, causing the unit to fail. Just to drive the point home, take the magnet and a piece of shim stock or a key. When you place the shim next to the magnet, you'll see that it clamps hard and tight against the face of the magnet. On a size 825 like we're assembling, if your fingers are between the magnet and the armature, they will get pinched, and in a size 1225, you might do permanent damage. We start installation by mounting the magnet to a plate that is non-magnetic material. This mounting needs to be square and concentric to the shaft. This non-magnetic requirement is noted in both the catalog and the installation manual. If the mounting surface is steel or iron, it will provide an alternative flux path for the magnetism and the unit will perform very poorly. Next, we will assemble the armature, auto gap pins, and the hub. Slide the white springs onto the bosses on the back of the armature. Place the output hub over the springs and turn the unit over so that the friction face is up. Thread the auto gap pins through the armature into the hub and tighten with an Allen wrench. Check to make sure that the white springs are free to move and not captured under the shoulder of the auto gap pins. Now slide the armature back against the hub and then slide the detents along the spring against the armature face. Add the bushing to the output side of the hub and loosely tighten so that it is secure in the hub. At this point, we have our magnet mounted to our non-magnetic surface and armature and bushing assembled but not yet on the shaft. We're ready to assemble the armature to the shaft. As noted earlier, with no power on, the permanent magnets will try to clamp the armature against the magnet. To ease assembly, we'll use the 3 1/16 inch thick steel shims to create a gap. Being careful of your fingers, slide the armature and bushing assembly onto the shaft. Now to continue, we will need to power the unit. Common options for a 90-volt unit will be the MCS 103-1 or the CBC 300. Both are adjustable output controls. While both are rated as 90-volt controls, each can output to slightly over 100 volts DC at maximum. That's normal. If you're assembling an ER 1225, the MCS 805 is the power supply of choice. Warner Electric electrically released brakes are polarity sensitive. Make sure you are wired to the terminals properly. You will now need to power the control, but ensure that other machine functions are safely off or disabled. Apply voltage to the magnet. This may allow you to easily remove the 3 shims. If not, adjust the voltage up or down until the shims slide out freely. With the shims removed, but power still on, press the armature against the magnet. Then finish tightening the bushing. As you do so, an air gap of about 1/16 of an inch will be created. Now remove power to the magnet and the brake will engage. The next step is to adjust the release voltage properly. Start with the control turned to 0 and slowly turn the power up until the magnet releases. Now continue to increase the voltage until the armature re-engages. Note the voltage at that point. Because the 2 magnetic fields are no longer in balance, the unit is engaging. In some instances, the control may output greater than 90 volts. That's normal. In some cases, you may get the control to full power and the unit may not re-engage. That's okay. In that instance, simply slide the armature against the magnet and it will clamp up. Now, starting from the full power position, slowly turn the control power down until the unit releases again. This will be at a different point than when you were turning up from 0. That's normal. Note the dial position or the voltage at that point. Now, set the control to halfway between the point where the unit engaged at the top and when it released when you were turning the power down. By setting the release point midway between these 2 values, power can vary somewhat and the brake will still release cleanly. We ensured we are properly mounted to a non-magnetic surface. The armature was assembled with proper air gap set. We adjusted the set point so that it is in the middle of the engage and release range. At this point, your electrically released brake will engage when power is removed and release cleanly when power is applied. Electrically released brakes are factory burnished to ensure the unit will achieve rated torque. However, during handling and installation, static torque may have been affected. Therefore, reburnishing on site is recommended. Burnishing is achieved by cycling the brake on and off in the application. Ensure that the system can operate safely. During burnishing, expect that the system will cycle 25 to 50 times. The brake can cycle at 5-second intervals, but your cycle rate may be dictated by the mechanics of your specific machine. Burnishing will encompass bringing the machine to normal speed and then engaging the brake. You will repeat this process at least 25 times. It is permissible to run your machine empty if that does not have a significant impact on the inertia stopped by the brake. After completing at least 25 cycles, apply a torque wrench to the output of the engaged brake. You should measure at least 125 foot-pounds for a size 825 brake and at least 400 foot-pounds for a size 1225. If you achieve the target torque, then your brake is achieving rated torque and no further action is needed. If after 25 cycles your brake is not achieving the target torque levels, repeat the process an additional 25 times. If after a second group of 25 cycles the unit is still not performing as expected, please contact us at Warner Electric Technical Support. If you continue to struggle with the installation or adjustment, please contact us at Warner Electric Technical Support. Thank you for your time and attention.